So what I did was I went to Desmos, and I suggest that all of you do. So you can go to Desmos, load it up on your phone or what have you, and put in these three curves. And you're going to see this graph a lot nicer. And take a look at it. And the thing to notice is that the linear function is always going over and up by the same amount. That's what's called slope. So it's a constant rise. Our quadratic function, it has a step function, but the step function stays the same throughout the whole thing. What gets really, really crazy is the exponential function in the way that it rises, and it takes off like crazy. So it rises nice and slow for a while. You'll notice that it's below the linear function for a while, and then all of a sudden, boom, it's gone, and it just makes that jump. And this has a lot of impact on things like bacteria growth, on population dynamics, on saving money, on loans, on borrowing money, that there's a time when all of a sudden the exponential curve just, boom, takes off, and there's no coming back. The numbers just explode. Think for a minute of leaving that lunch in your locker that you forgot about. You know, that nice sandwich that mom made for you, or maybe that little soup and pasta that you had in that Tupperware, and you left it in the locker. And it was fine for the first day, and it was fine for the second day. But what's happening is little bacteria are multiplying. And maybe it started with only 100 bacteria. Then the next day it was 200. Then the next day it's 400. Then the next day it's 4 times 16. 1,600. So it's growing exponentially. Then all of a sudden, 3 days later, you open up that sandwich and you've got this green, fuzzy thing. And the bacteria just occurred. Well, no, it didn't. But it was growing exponentially, and all of a sudden it hit that critical point where all of a sudden the next jump is so large. It's absolutely crazy. So let's look on the back. Which of the relations are functions? Well, they're all functions. Why are they all functions? Because they all have only one y value associated with each x value. That's the definition of a function. So all of these are functions. Each x value has only one associated y value. And that goes back to that vertical line test that we used to have. So if I think about a line, there's the line that we had. If I think about the parabola that we just graphed, there's the parabola. And if I think about the quadratic that we just graphed, not the quadratic, the exponential, there's the exponential. So linear, quadratic, exponential. They all pass the vertical line test. For every single x value, there's only one associated y value with it. So they are all functions. What's the domain and range for each of them? Well, might as well keep this same order going here. So for the linear one, the domain is all the possible x values have a place on that line. What about the range? Well, all the possible y values have a place on that line. So all the x values are important, all the y values are important, and that's the way we say that mathematically. And once again, it's a y with a funny looking e with an r, and this means that the y values are our elements or members of the real numbers system. And that's like a group of numbers, and those are all your positive numbers, all your negative numbers, all your whole numbers, all your fractions, all your decimals. Everything you know is a real number. The only number that you know that's not a real number, the only thing that doesn't exist in the real number system is anything with a negative under the square root. Those don't exist in the real number system. Okay, they're called complex numbers. They don't exist in the real number system. Okay, so what's happening over here? What's the domain and range for this puppy? Well, I remember the equation was y equals x squared minus 1. I know that this has a vertex of 0, negative 1, and you should know that too, which means that I've got a minimum value here of negative 1, which means when I look at domain and range here, x can be anything, and y needs to be greater than or equal to negative 1, and it can be anything after that. And we really should be putting in these special little brackets. It's the difference between having a full, complete mathematical statement and us just uttering words to people. So instead, if someone said, what color is the car? And we said the car is red, that's what this says. If we don't have those, it's kind of like us saying, red. And so, you know, it's nice of us to have the complete package there. And this one here, exponential function, it's an increasing exponential function, which means that we know all exponential functions are going to go through 0, 1. We know that. And this must have a base that's greater than 1 because it's increasing. X is an element of the real numbers. And y must be greater than 0. Has to be greater than 0. It can never, ever, ever touch 0. It can't have an equals. And y is an element of the real numbers. Let's identify any max or minimum points. Well, this is going to have no max, no minimum. It keeps going and going and going. As x approaches positive infinity, y is approaching positive infinity. As x approaches negative infinity, y is approaching negative infinity. And what that means is that when I go this way, I'm going this way. And when I go this way, I'm going this way. That's all that means. Do we have any max mins? Oh yeah, you got a minimum point. Minimum value at y equals -1. But it did say a minimum point, so I'm assuming they want 0, -1, because that's how you talk about a point. You give it a x value and a y value. And this one, do we have any max or minimum points? No. There's no max. It goes on forever. So as x approaches positive infinity, y approaches infinity. And what that means is, as I go this way, I go this way. That's what that means. And there's also no min, because as x goes to negative infinity, y is approaching 0. So there's no min. In essence, it's not going to hit a minimum value, but it's bounded. We like to say that it's bounded. It can't go below 0. It can't be 0, but it's going to get closer and closer to 0. So the real mathematicians in the group are going to say it's a bounded minimum. But it's not an absolute minimum. There's not a value that I can get to. And what that goes back to talking about is that as I go this way, I'm going this way, but I can't go below this horizontal asymptote. I'll stop the video there and we'll be back.